Hello and welcome to the BMC Quick Course series. My name is Greg Tubin and I'm a product development architect based in the USA. In this session, I'll introduce you to MainView for Java Environments version 1.0. First, I will point out some of the messages you will see at startup. This will help you to identify that the product is working properly. After that, I'll explain how to control the JVM discovery process, which identifies the JVMs on your system. And finally, I'll show you the first view you will see on entry to the product, along with the views that are available without defining targets to MVJE via the path service point. This will include all discovered JVM views and NGL history data. Here you see initialization through auto discovery messages in blue. Let's take a look at them. MJE INI01 shows you version info. MJE INI08 will tell you what the debug level. Normally this is set to 1. MJER TG01W. You will see this the first time you go into the product. It is normal to see this the first time you start, as there are no defined JMX targets at this point. Next you'll see the BMC NGL messages. These come out from NGL or the next generation logger, and it's just letting you know that we're connecting to the logger. Then you will see the discovery type. MJE SFE06 if auto discovery is active, and then down in the green, MJE TDI01I if time discovery is active. MJE MVS01 lets you know that we have connected successfully to the CAS and initialization is complete for MainView for Java environments. Then, if you have service points, you'll see MJE SPT00I each time a service point is attached. In the syslog, you'll also see MJE SHM00 indicating that the script to start MJE JVM is executing. And then you'll see MJE JVM00 and MJE JVM02 messages letting you know that MJE JVM is starting and what build and PTF levels the components are at. There are three types of discovery methods. If you're running ZOS 2.2, auto discovery is the default method. Auto discovery is the most effective method for discovering JVMs on your system. However, auto discovery is the default method only if the CSV fetch exit is enabled. If the CSV fetch exit is disabled, the default is to set the time discovery method. The auto discovery method will discover all JVMs and threads that are active while MVJE is active. If for some reason you would rather use time discovery, you can change the default by setting autodisk equal no in MJE INI. The time discovery method runs on an interval you specify. The default is every 10 seconds. If discover is already queued, then the interval is skipped. This type of discovery searches the process table in USS for JVMs. Take note that if you select a long discover interval, short-running JVMs and threads are more likely to be missed. Finally, there is the force discovery method. You can type the action discover to force a discovery to take place. Depending on whether discovery has run recently or is currently running, issuing the JVM disk view will also force discovery. When you first enter the product, you will see the EasyJE view. The only service point will be the PAS, MJE GTC in this case. Your eyes will be drawn to the Setup JVM Targets entry. Another quick course will describe how to set up MVJE service points for MJE JVM or JMX targets. For this quick course, we'll be focusing on the first two areas on the left side of the menu. This is the easy menu when a JMX service point is the context. You can see that the menu is the same except for the added options on the right side. These options will be explored in JMX usage and JMX environment sessions. Let's look at the All JVM views. This data is available for all discovered JVMs regardless of whether the JVM is a service point. The current active JVM hyperlink will take you to the JVM disk view. The JVM disk view shows the discovered JVMs. The job name hyperlinks takes you to the EasyJE menu for that target. The JVM type hyperlink takes you to a view in the appropriate MainView monitor. The process ID hyperlink takes you to the USS Easy menu for the process. The target and JMX columns indicate whether a process is a target or whether the JMX port has been verified for this process. You will notice that the last request date and time field says no request. This means that there has been no specific request for CPU data, and the times displayed are only for those tasks that have ended while MVJE is up. If you enter CPU in the command column and press enter, the CPU time will be requested. Here you can see the times have been updated as well as the request time. The JVM dCPU view does this for all the JVMs. You can also hyperlink on the last rec time to cause the action for any JVM. The hyperlink on JMX takes you either to the EasyJE menu if yes, then if anything else but no, to the TGT Prof view. The hyperlink for target yes will take you to the JVM DTGT view for the target. We will look at that view next. Here is the JVM DTGT view for the target. This view shows you the targets that are active and what ASID they are running in. In this case, you can see there are two JVMs with JMX in the same ASID. For more information on targets, view the quick course on defining JMX targets. Now we will select Active JVM CPU Usage. The JVM dCPU view shows you the total CPU used by the JVMs for all JVM-associated tasks that have been active while MVJE has been running. Because the CPU collection is an asynchronous process, sometimes you will see an incomplete result time. If you press enter, only those with complete data will be requested. Hyperlinking on the job name will take you back to the JVM disk view. You will notice that the JVM disk view shows different request times for the JVMs that showed incomplete on the previous view compared to those that had all data returned on JVM dCPU. This is because a new request was skipped until no more data was being returned. Now let's talk about NGL log data. CPU data is written as long as we are connected to NGL. JSOS SMF GC data takes a little more effort. Let's take the JVM CPU history hyperlink first. JVM CPU shows you the CPU data for each JVM when it shuts down. By default, the first 400 records are returned. You can click on the plus sign to add filters to the query. You can enter JVM type of JZOS and max records of 20 to show the last 20 JZOS jobs that finished. You can see on the status line that only 20 records were returned and we're only viewing JZOS jobs. Similarly, you can set filters on job name, date, and time. Let's talk about collecting JZOS SMF data for garbage collection. First, SMF IEF U84 exit should be enabled for sys, STC, and JES2 or JES3 depending on your environment. SMF should be set to collect SMF 121-1 records. You must tell JZOS to collect SMF data if you want JZOS jobs to collect SMF for garbage collection. If you want to collect SMF for all JZOS jobs, you can set JZOS_JVM_SMF_logging equal true in etc profile. Alternately, you can add that to the env var for each JZOS JVM you want to collect garbage collection data for. Now, let's hyperlink to the JZOS SMF GC data. We will hyperlink again on the plus sign to expand the retrieval filters. Let's say you want to look for all the JZOS garbage collection stats for JZOS jobs that start with B. You type B* in the job name field and press enter. As you can see, only jobs starting with B were returned. This concludes the introductory session. Please review the JMX and setting up targets sessions next. Thank you for your time. For more information on any BMC mainframe product, please visit the URL shown here.